Good morning, everyone. Today's session is planned in this way. First 1 hour, I shall discuss certain problematic part at advanced level. Then I'll give you enough time at the remaining half an hour. You can post me your doubts. Hope you started doing your assignment, so-called DPP. And in DPP also, I find certain questions to be discussed. I find certain questions are difficult. I'll discuss that few questions from the assignment as well. Apart from that, if you have any other doubts personally, you can just ask me. That is to be done in the latter half of the part. Okay. This is from the DPP. Yesterday I got a couple of the questions from the student. Let me solve this. 2 mole of an ideal gas is changed from initial state 16 atm 16 6 liter 16 atm 6 liter to a final state 4 atm 15 liter in such a way that this change can be represented by a straight line in PV graph. So let us draw that PV graph. In general, this is the PV graph. In general, PV graphs are drawn at constant temperature and they are called isotherms. That we know. But he is asking the maximum temperature attained by the gas during the above change is. So straight line, I represent with a straight line. Let me see. Suppose it is a straight line like this. You are getting a straight line in PV graph. You're getting a straight line in PV graph. It implies the temperature during the process is not constant. Let it be state 1, initial state. Let it be state 2, the final state. You should get a rectangular hyperbola. Already I told you, if PV is equal to constant at constant temperature, it is called rectangular hyperbola curve. But you are not getting a rectangular hyperbola. You are getting a straight line in PV graph. It implies it is a combination of many isotherms. And during this process, somewhere you are getting maximum temperature. Let us suppose this is the point where we are getting maximum temperature. Let the point be x and the coordinates can be v comma p. And here the volume is 6 liter and here the volume is 15 liter. 6 and 15. The pressure here is 16 atm and here the pressure is 4 atm. Here the coordinates are 6, 16, and here the coordinates are 15, 4. Let these are x1, y1 and x2, y2. Let me find slope of the line. Slope of the line is equal to y2 minus y1 by x2 minus x1. Difference of y coordinates by difference of x coordinates. y2 minus y1, 15 minus 6 divided by x2 minus x1, 4 minus 16. So this is minus 9 by 12, or you can say 3 3s, 3 4s, minus 3 by 4. That is the slope. That is the slope of the line. Yes, Sai Vardhan.
Sir, y2 minus y1 means 4 minus 16, no, sir? You written reverse, sir. There 15 minus 6, x2 minus x1 you written. Slope.
X1, okay, sorry. Pressure is taken on y-axis. No? I'm sorry. Just a second. Pressure is taken on y-axis. Correct? So, better I'll write the coordinates as 6, 16 changes to 15, 4. Correct?
Yes, sir.
Now this will be x1, y1 and this is x2, y2. Now is this okay? Slope of the line is equal to y2 minus y1 by x2 minus x1. Now y2 minus y1 is 4 minus 16 divided by 15 minus 6. This is minus 12 divided by 9. Or I can say minus 4 by 3. That is the slope of the line. What I am trying to do is, I assumed that the maximum temperature is attained at a point x with coordinates v comma p. And the point x lies on a straight line whose slope is given by minus 4 by 3. Now I have a point v comma p and slope 4 by 3. Slope point form. How to find the line equation? Y minus y1 is equal to slope into x minus x1. Right? You can take any point, some 6 comma 16 I take a point. Y coordinate is p. Y1 can be written as 16, that is equal to slope 4 by 3. X coordinate is volume and x1 is 6. Now you have 3p minus 48 is equal to minus 4v plus 24. You can write 3p plus 4v is equal to 24 plus 48. 72, correct? Now I got a line equation. I got a line equation. To get the maximum temperature, can you please suggest me any method based on your basic mathematics? Anyone? What is the way to find out? 006. Sai, please tell me.
Sir, derivation 0 out first derivative.
Okay. Whom should we take first derivative?
Sir, we will write. We will write pressure in terms of volume, sir.
1 second. 1 second. Is it 676?
Yes, sir.
One by one, please. 676. Please tell me.
Sir, we will write pressure in terms of volume, sir.
Okay.
Sir, after that, using the ideal gas equation, we will get T is equals to PV by NR.
Okay.
PV by R. 2R, sir. PV by 2R. And after that, using the maxima condition.
What is the maxima condition?
First derivative is equals to 0.
Okay, done.
First derivative is 0, sir.
Okay, very good.
Yes, sir.
Now, can I use little more mathematics, AM and GM, progressions, arithmetic mean and geometric mean? Can I use arithmetic progression and geometric progression to find maxima and minima? At least maxima as of now required. Suppose the gas is ideal. Yes, it is given. PV is equal to 2 RT because 2 moles are given. PV equal to 2 RT. Can we write T is equal to PV by 2R? T is equal to PV by 2R. You must get maximum temperature. To get the maximum temperature, product of P and V should be maximum because 2 and R are constants. To get the T max, product of P and V should be maximum. And the condition in using progressions is AM is greater than or equal to GM. Or I mean to say, put 3P is equal to 4V. Now tell me, if you put 3P is equal to 4V, then you will get 3P as 3P. 4V is also written as 3P. Then you will get 72. P is equal to 72 by 6, which is 12. Now, in terms of volume, let me write down. In a place of 3P, you can write 4V plus 4V, that is equal to 72. Then V is equal to 72 by 8, 9. What I mean to say, if 3P is equal to 4V, then the product of pressure and volume will be maximum. Then what is the product of PV, or what is the T max? T max is equal to product of PV, that is 9 into 12 divided by 2R. And what is the value of R? You have T max is equal to 12 into 9 by 2 into R value, 1 by 12. Two ones, 2 6. Simplify, please. What will be your answer?
$648, sir.
Okay. Now I have given you the simplest method by using arithmetic and geometric progression. You told me one more thing, na? Like first derivative should be equal to 0. Please verify within 5 minutes and check your answer, whether it is 648 or not. Deepak, do you want to say anything? 871. Yes, Sai Vardhan, 047.
Sir, one say that how you written that 3p is equal to 4v.
That is the condition for AM is greater than or equal to GM. Do you know the progressions, arithmetic and geometry progressions?
Yes, sir.
Yes. Then you might know that inequality also AM is greater than or equal to GM.
Yes, sir.
A plus
Okay, sir.
B by 2, that is arithmetic mean. Correct?
Okay, sir. I understood.
Right. Double 41. Tell me, Tanay.
Sir, can
Yes,
we
sir.
say product of present volume is area under the graph?
You can see.
Then also we can get, sir.
Okay, that, no problem. A question can be solved in n number of ways, and you need to find the easiest method so that you can save time.
Okay, sir.
Anything, if you draw a graph on y and x axis, if the product of y coordinate and x coordinate is nothing but area. So moving on to the next question. At a certain temperature, it is not from your DPP, it is not from your assignment. at a certain temperature for which RT is equal to 25 liter atmosphere mole inverse. The density of a gas in gram per liter is equal to 2P plus 0.02 P square, where P is the pressure in atmosphere. What is the molecular weight of the gas in gram per mole? If the gas were ideal, what is the relation between pressure, molar mass and density? Pm is equal to dRT. Or you can write D is equal to Pm by RT. So here density and pressure are directly proportional. But in the given equation, it is not so. Implies definitely the gas is real. From this, can I take P common? 2 plus 0.02 P D by P is equal to 2 plus 0.02 P. Now I want the value of D by P at limit P tends to 0. Why I am doing that? P tends to 0, very low pressure. That means when P tends to 0, automatically molar volume tends to infinity. Pressure is very low, almost 0. So volume will be very high. So almost tends to infinity. That means either large molar volume or whether P tends to 0. Under these two conditions, the gas can become ideal. The gas can become ideal. Because when the molar volume is very high, molecules do not exert force on any other. No molecular attraction. Number 2, volume of one molecule when compared to total volume is very neglected. That are the conditions for ideality. So when P tends to 0 or molar volume tends to infinity, then the gas becomes ideal. Now D by P, when limit P tends to 0, what is the value? 2. Now D by P, limit P tends to 0. So this will be for ideal behavior. That means for an ideal gas, D by P is equal to 2. Now here for ideal gas, what is D by P? M by RT. And according to this particular, this can be written as 2. Then molar mass is equal to 2 RT. 2 into, what is the value of RT given? 25. So this will be 50 gram per mole. Actually, this is not for ideal. The given expression is not for ideal, but I converted this expression for ideal by putting limit P tends to 0. So your answer would be B. Check. If you have any questions, let me know. 989. Tell me. Yes, Ram Pratik.
సార్
Yes, please tell me.
సార్ ఇప్పుడు ప్రెజర్ టెన్స్ టు 0 అంటే ఆల్మోస్ట్ 0 కదా సార్?
Yes.
ఆ కండిషన్లోనే ఐడియల్ గ్యాస్ అవుతుంది సార్.
Yes.
అంటే ఐడియల్ గ్యాస్ ఎగ్జిస్ట్ ఇన్ వెరీ లో ప్రెషర్.
Very low pressure or very high temperature.
అంటే ఐడియల్ గ్యాస్ కండిషన్.
Ideal, why not? Why? Because when pressure tends to zero, then only molar volume tends to infinity. Then only molecules will not have any attraction on each other. And volume of one molecule when compared to total volume is neglected.
ఇప్పుడు అట్మాస్ఫిరిక్ ప్రెషర్ లేకపోతే మన ఇప్పుడు ట్రోపోస్ఫియర్ ఇందులో ఉన్న గ్యాసెస్ అన్ని
That is the reason. That is the reason no gas is ideal.
ఓకే.
We consider every gas to be ideal. We take that assumption. Okay, we take that assumption if the gas were ideal. In practice, at room temperature or at any considerable pressure, no gas is considered ideal.
ఓకే సార్.
If you are comfortable with this, I can move on to the next question. Five minutes time. Try to solve this one. Yes, 032, 032.
Sir, one option, sir.
Second option.
Yes, sir.
Just let me check out. Okay, done. Very good. Please put your hands down. Anybody else did this one? Yes, 032. Can you help us? Zero 032. Can you help me? Manideep, tell me.
Sir, Total volume is V plus 2V plus 3V plus whole and n plus 1 by
Yes, 133.
2, sir.
032. Tell me.
So total volume is V plus 2V plus 3V up to NV, sir. It is n into n plus 1 by 2V.
V plus 2V plus so on up to NV. What is this?
Total volume, sir. When the stopcock is open, sir.
Okay, very good, very good. And how do you find the total volume? Which
So
progression?
total volume is in one. Sir, in one container the pressure is P, sir. Like that, n containers are there.
Right?
Total pressure is P1,
Sir,
P1 by P2 is equals to V2 by V1.
sir, if the gases are unreacted, then we can add volumes individually.
Okay.
So that we get volume equals to V plus 2V plus and so on NV.
Okay.
We take V as common and we solve it n into n plus 1 by 2 into V.
N into N plus 1 by 2. Where is this coming from?
So, and sum of n natural numbers.
Very good. So which progression it is in?
Arithmetic progression.
Very good. So this will be your final volume. Is that okay?
Yes, sir. Yes, sir.
Okay. Then what about pressures?
From ideal gas equation, PV equals to nRT.
Okay.
P into V into n into n plus 1 by 2 equals to n into RT.
Okay. What about the pressure in the first container? It is given P. What is the pressure in the second container? It is given that pressure of the first container is P. Then what is the pressure in the second container?
Sir, P1 V1 equals to P2 V2.
Very good. Why? Because it is mentioned same temperature.
Yes, sir.
Right. Deepak, please put your hands down.
Yes, sir.
Right. So guys, remember the volume of first vessel is V, second vessel is 2V and so on. Automatically, volume is, I write here. The volume of vessels are given V, 2V, 3V and so on up to NV. As the temperature is fixed, all containers are at the same temperature. You know, if the first container has pressure P, automatically second container will have pressure P by 2 because volume is doubled, pressure is reduced to half. Correct? Then this will be volume is tripled, so pressure is reduced to 1/3 and so on. And what is the pressure here? P by N. Correct now? Now you can apply a relation. What is that? P1 V1 is equal to P2 V2, that is equal to so on, that is equal to Pn Vn. Okay, now simplify and you will get the answer, second option. Very good. Okay, 5 minutes time. Which of the following statement is not true? This is related to kinetic theory of gases. Yes, 441. Tell me. Yes, Tanai. Tanai, tell me. 441. Yes, 611. Zero 47 676. Tell me. 441. Zero 58. Now, the question under discussion is, which of the following is not true? Which of the following is not true? The ratio of mean speed to the RMS speed is independent on temperature. Mean speed is under root 8 RT by pi m. RMS speed is under root 3 RT by m. As RT by m cancel, it is independent on temperature, correct? So option A is right. B, the square of the mean speed of molecule is equal to mean square speed at a certain temperature. The square of the mean speed. Suppose the speeds are 2, 3. What is the mean of this? 2 plus 3 by 2. Okay, for convenience, I take 2, 4. Then what is the mean of this? 2 plus 4 by 2, that is 3. Okay. Square of the mean speed. So this is the mean speed and square of that. Square of mean speed is equal to 3 square. That is 9. And mean squared speed. Squared speed. This will be 4 plus 16 by 2, which is 10. Are they equal? No, not equal. Wrong. Mean kinetic energy of a gas molecule at a given temperature is independent of mean speed. Correct? Why? Because kinetic energy for n moles of gas is equal to 3 by 2 nRT. And we know Boltzmann constant, which is R by Na. Boltzmann constant. R and Boltzmann constant, they are one and the similar. R is for mole, K is for molecule. So kinetic energy directly proportional to temperature. But it is given that at any given temperature. So temperature is already constant. So kinetic energy will remain constant. correct? The difference between RMS speed and mean speed at any temperature for different gases diminishes. Diminishes means approaches to zero, or decreases, approaches to zero. No difference in the sense. As larger, if larger molar mass diminishes as larger molar masses are considered, correct? I think I told you. Look at the graph. Maxwell distribution of molecular velocities graph, if you consider. At a particular temperature, I got a graph like this. And let it be at a temperature T, and let the molar mass as M1. And the yellow color, if we consider this, the yellow color is at a temperature T, but molar mass is M2, and M2 is greater than M1. How would I know that M2 is greater than M1? Simple funda. For the first one, this is Cp for the first, and for the yellow one, this is Cp2 for the yellow one. We know Cp is equal to under root 2RT by M. So if the molar mass is larger, Cp is smaller. So yellow color Cp is smaller. That is Cp2 is smaller than Cp1. No doubt M2 will be higher or larger molar mass. So at a given temperature, at any temperature, if we consider two different molecular masses, the larger molecules are better, heavier molecules will have narrow distribution. Here it is broad. What do you mean by narrow distribution? I told you earlier, Cp, C bar and CRMS, they lie in the vicinity. They lie in the vicinity. Pakka pakkane untai. Here also they lie in the vicinity. When the peak is broad, the gap between Cp, C bar and CRMS will be little broad. But when the peak is narrow, that means the difference between RMS speed and mean speed will be almost close. That is the reason, try to remember this fundamental. Heavier molecules have narrow distribution. Heavier molecules will have narrow distribution. The peak becomes narrow. Yes, Ashish. How would I know, man, before 10 seconds? Okay, I will explain all the first options are okay, first two options. Right, option D. When we discussed Maxwell distribution of molecular velocities, we came to know that the probability of a molecule having speeds between C and C plus dc, 1 by n dnc by dc, depends on molecular mass and temperature. When we draw the graph for heavier molecules, you will find the yellow color graph. Yellow color graph is narrow. And we know Cp, C bar and CRMS, they lie in the vicinity. They're in the ratio 1 is to 1.124 is to 1.228. All of them are very nearby. When the peak is broad, the difference between the speeds is little high. When the peak is narrow, the difference between speeds is small, almost diminishes, going to decrease. So option D is also correct. Just go through this. I'll give you another question. Yes, Tanay. Double 4 1. Tell me. Yes, Tanay.
Hello, sir.
Yes, please.
Sir, can you explain the questions 13th and 14th? In the
Where is
DP.
that? In assignment.
Yes, sir.
Please wait. I'll explain. Okay.
Okay, sir.
I have three more questions, and from that, then I can discuss the questions from DPP. Okay. Try to solve this question. 5 minutes time. I'll open that DPP now. I can give you a clue if you want. I can give you a clue. The clue here is, what is the mean molar mass? What do you mean by mean molar mass? Suppose there is N1 mole of A whose molar mass is Ma, and N2 mole of B whose molar mass is B. If I mix them, what is the mean molecular mass or average molecular mass? N1 M1 or N1 Ma, or you can say Na and Nb, Na Ma plus Nb Mb by Na plus Nb. That is the way to find molecular mass average. In the 2-liter vessel, you have the other one is 3-liter vessel of the same two gases. In the first one, mole ratio is 2:3. So number of moles of A by number of moles of B is equal to 2/3. In the second one, number of moles of A by number of moles of B is equal to 3/5. Okay. Both gas mixtures have the same temperature and same total pressure. Then you can apply ideal gases equation. PV is equal to nRT. P V is equal to N. Here N is total number of moles. R T for the 2-liter vessel. What about the 3-liter vessel? Brother is same. P into 3 is equal to Na dash plus Nb dash, that is total moles, into RT. Again, both are at the same temperature. If you divide, RT cancel, P and P are cancel. Then you have Na by Nb divided by Na dash plus Nb dash is equal to 2/3. From this, can we write Na is equal to 2/3 of Nb? Correct? What we need to try to do? We need to reduce the number of variables as much as possible. So write Na in terms of B, and here also same. Na dash is equal to 3/5 of Nb dash. Na 2/3 of Nb plus Nb divided by Na dash 3/5 of Nb dash plus Nb dash is equal to 2/3. Two by 3 plus 1, what is that? 5/3. 2/3 plus 1, 5/3. 5/3 of Nb divided by 3/5 plus 1, 8/5. Nb dash is equal to 2/3. So you may write simplify. Just a second. 5 NB by 3 into 5 by 8 NB dash is equal to 2 by 3. You can cancel 3 here. That's it. I think nothing more cancelled. So we have a ratio NB by NB dash is equal to 2 into 8 by 5 into 5. Now finally, molar mass average. You are finding out between these two. So I can say molar mass average is equal to, here A means the number of moles in 2 liter vessel. So that will be Na plus Nb into molar mass plus, okay, just do this till here. I'll open the another slide and explain. Do this till here. I'll open the other slide and explain. Do till here. So I got NB by NB dash is equal to some 16 by 25. I am opening the another slide. This is the question. And I got finally NB by NB dash is equal to 16 by 25. Continuation. Molar mass of the average. What is that? NAMA plus NBMB by Na plus Nb. Now here I write molar mass average is equal to Na. Here we have 2 vessels and both are mixed. In both the vessels we have A. So can we write Na as Na plus Na dash, that will be total moles of A into Ma plus Nb plus Nb dash, that is the total moles of B into Mb divided by Na plus Nb, total moles of A, that is Na plus Na dash plus total moles of B, Nb plus Nb dash. Now simplify, you'll get the answer. We got a relation between Nb and Nb dash, 16 by 25. Similarly, try to get the relation with Na and Na dash. Simplify and tell me the answer. Quick, 2 minutes time. Tanai, tell me. 441, tell me.
The first option.
Okay. Let me verify. Yes, correct. Okay, in the meanwhile, others, please open your yesterday's assignment. Somebody asked me a question. Sir, in the assignment given, 13 and 14 are doubts. So, hope everybody understood this one. Moving on to the next question. I think this is the 13th question. So guys, I think it is the question asked, question number 13. And who asked this question? Let me know the name. Okay, Tanai. Tanai, is this the question 13? Tanai, is this the question asked?
Yes, sir. 13 and 14.
Okay, okay. Everybody, question number 13, it is posted now. Excellent concept, very, very good concept. Critical behavior. So we need to write critical isotherms first. If you draw the graph between pressure and volume, I think we got something like this. Liquid and gas can coexist only at this particular point, critical point. And the temperature is critical temperature, which is 8A by 27 RB. And this corresponding volume is a critical volume, which is 3B. And the corresponding pressure is called critical pressure, which is A by 27 B square. These are the critical constants. Okay, remember, critical volume is not fixed. So most reliable is based on critical pressure, based on critical temperature, critical volume is fixed. That means volume of a gas is dependent on pressure and temperature. If these two are fixed, then only volume can be fixed. Now, a scientist proposed the following equation of state. P is equal to RT by Vm minus B by Vm square plus C by Vm cube. Vm mane molar volume. If this equation leads to critical behavior, then critical temperature is, okay, generally critical temperature is ATA by 27 RB if they satisfy van der Waals equation. That is P plus A by Vm square into Vm minus B is equal to RT. Okay. If this van der Waals equation is obeyed, this is the critical temperature. But it is something, I think it is not in the form of van der Waals equation. Some other equation. Now what is that other equation? P is equal to RT by Vm minus B by Vm square plus C by Vm cube. Okay. Some equation. Critical behavior, definitely critical point. Can we say at critical point, dou P by dou V is equal to 0? That is slope is 0. Slope is 0. Now apply here also dou P by dou Vm molar volume is equal to 0 at critical point. At the critical point, volume and pressure are fixed. Temperature is also fixed. No change. So I can write dou P by dou Vm is equal to 0. That means we need to differentiate this pressure with respect to molar volume. Tell me, differentiate and tell me. This can be written as minus RT by Vm square. That is derivative 1 by V is minus 1 by V square plus 2B by Vm cube and minus 3C by Vm to the power of 4, that is equal to 0. Any questions? Okay. Now, as it is the critical point, better write temperature as critical temperature. Okay. And volume will be critical volume. Can we also write this as minus RTC plus 2B by Vm minus 3C by Vm square is equal to 0. What did I do? Vm square cancel or multiply with the Vm square on both sides. This may be also written as RTC into Vm square LCM minus 2B into Vm plus 3C is equal to 0. Now I got quadratic in terms of Vm square, Vm power 1 and independent term. So this is in the form of Ax square plus Bx plus C is equal to 0. There we'll have two volume roots, but as it is a critical condition, the two roots must be identical because it has only one root. Determinant should be 0. B square minus 4AC is equal to 0. Okay, what is B square? 4B square, correct? Here B is minus 2B. 4B square minus 4AC. So what is A value here? RTC. 4 RTC and into 3C is equal to 0. Correct? 4B square is equal to 4 3 is 12 RTC into C. Therefore, TC is equal to, critical temperature is equal to 4b square by 12rc. So undoubtedly it will be b square by 3rc. If the gas obeys Van der Waals equation, critical temperature is equal to 8A by 27 Rb. Now the given equation is not Van der Waals equation, but we know that at a critical point dou P by dou Vm is equal to 0. And we are getting a quadratic equation. For quadratic equation, we will get two values of volume. But at a critical point, critical volume is only 1. So the two roots can be identical if and only if determinant is 0. B square minus 4AC equal to 0. Please solve that. I'll move on to question number 14.